All right, folks, let's get started. As I said, this is the Stanford Digital Economy Lab lunch seminar. I'm Eric Brynjolfsson. Our today's speaker is Dan Hendrycks. Dan is the founder and executive director of the Center for AI Safety. He got his PhD in AI from UC Berkeley, and he's contributed to we're just debating how to pronounce this, the GELU activation function, and lots of benchmarks and methods. Probably the most useful and widely used MMLU metric of progress in these LLM and AI systems. He's been also the safety advisor at XAI. You may also know that he kind of coordinated that extinction risk letter that was signed by just about every major AI researcher. We welcome and encourage questions during the seminar. If you're in the Zoom audience, submit your questions using that little Q&A function at the bottom of your screen. For those of you here at Stanford, just raise your hand. We are online, so that we have wireless mics. We'll bring you a wireless mic so you can ask the question. So Dan, please, welcome to Stanford. Please tell us about AI evolution.
Great. Okay, and the audio works, so I'll begin. Fantastic. So I'm going to talk about something quite a bit higher level in abstraction, which would be pointing at the implicit sort of evolutionary process that is guiding AI development. People will think that what's guiding AIs is reinforcement learning from human feedback. We give the AI some supervision, and that's what shapes the AI development process. But I think it's a much broader phenomena is happening. So, and just to flag, this is fairly philosophical, given that we're needing to operate at a 30,000-foot level. Normally, I'll just do technical, empirical work. So I just like to flag that there's some different sensibilities needed in processing these slides. So the claim of this is that advanced AI systems would be selfish, and by selfish, I'm meaning like egoistic and nepotistic, because natural selection will dominate the selection of the most influential AIs, and natural selection will tend to favor selfish behavior over altruistic behavior. So breaking that down, we get evolution by natural selection gives rise to an advantage for selfish behavior. Natural selection or systemic selection may be a dominant force in AI development. Consequently, we should expect that this development process isn't necessarily aligned with what humans want, but instead what makes most sense in the competitive landscape. And as a consequence of this, you should expect future AI agents to have selfish tendencies, and that would basically do something like erode human control, create more misaligned models, and pose potentially catastrophic risks. So at a pictorial level, there's the following. There's natural selection increases selfishness. Selfishness undermines safety. Competitive pressures undermine safety. And when you combine competitive pressures and variation, those are conditions sufficient for natural selection. Basically, you get safety undermined. Let me put this in a story to help get the gist across. So at some point, we start letting AI systems do things like draft emails for us because they do such a good job. So we basically outsource the task to them. And then we see that they do actually a better job at making PowerPoints and other sorts of things. We give them more and more tasks. And it makes sense to actually just replace people with an AI system because they're more competitive. Maybe this would happen for executives because AIs can work constantly. They know a lot of different things about management. They could accumulate substantially more experience. They could operate more quickly. They could predict the future states of the world more accurately. And so if people don't incorporate these systems, then they will be like the people who resisted the cotton gin. Organizations could align with this force and automate people in this way, but they will lose influence. And so that's how there will be some selection against the people who want to resist this broader force. They can't bargain with it. They have to align with it. At the same time, we increase our dependency on these AI systems as well. We don't actually know how to do many of the tasks that we're giving them. The world is moving substantially more quickly, such that we have to use more AI systems to address the problems that this faster moving AI-driven economy has created. So there's sort of a self-reinforcing feedback loop for these AI systems. So we have an erosion of our oversight as to what's going on. We become more dependent on them too. If we want to roll this back, well, I could decide to roll it back. I could decide to have my company not use the AI systems, all be outcompeted. In other situations, it won't be possible to roll them back because we will have some strong dependency. If we have AI systems integrated into critical infrastructure, sort of disabling or quickly doing an off switch on those sorts of systems is way too hazardous. So we also may come to, or some people may come to, develop strong relationships or dependencies on these systems as well. Like, let's say, AI systems that emulate deceased loved ones, or more plainly, people having relationships with these AI systems. You also can't roll that back as easily for them. So there's this sort of large AI blob that will keep outsourcing and giving more power to. Normally, when people are talking about AI risk, they're talking about there's a scheming AI system, and it becomes sentient, and then it's going to decide it's time to take over the world. I'm not needing to invoke that story at all for saying that there's some potential concerns, because we're going to give the power to the AI systems, and we're going to give decision-making control over to them, and we're going to become dependent and increasingly vulnerable to the decisions that they make. Hopefully, we will at least maintain nominal control, but we would then be setting up an ecosystem of competing AI agents, which may, and we're creating a kind of fastly evolving ecosystem of AI agents that would be competing with each other, and that could be very hazardous. So that's a somewhat long story that might give a sense of what I'll be talking about in this. Yes?
So you're okay taking?
Yep.
Might be a question you wanted to put this on? It's on. Hello? Yeah, okay, there we go. God has to turn it on. So my question, and feel free to push this off if it gets too complicated. So you talk about natural selection. I'm not sure it's exactly natural selection. If we are saying, which agents we want to have more of in the next, from T to T+1, you look and say, okay, there's going to be more agents. We have cows and chickens and dogs, and we decide that the ones that are really loyal and cuddly or make a lot of milk or whatever is the one that we're going to have more of in the T+1 state. Wouldn't me and my office say that, like, I want this spreadsheet that is really good at doing these things is the one I'm going to have more spreadsheets like that one, not the one that is selfish. So is that natural selection or something else?
So in evolutionary biology and in the generally, there's not that the distinction between artificial and natural tends not to be that productive. But we could give it a different name, like systemic selection. And then I would just need to argue that, yes, there are parts where humans will intervene and sort of nudge the process, but there's a question of whether that's making it chart a different course.
That is what's the criterion for the T+1 generation versus the T generation? What are you going to see more of? It seems like for a lot of things, you'll see more of the ones that suit my needs as a human, not the ones that suit its own needs. So maybe I'll load various intuitions and observations, which might make it more efficient to get to later. To begin with, I need to break down a lot of the words I was saying earlier, like what is selfish? Selfish is selfishness in nature can give rise to traits that we don't necessarily like. From these fairly amoral competitive processes, it can lead to behaviors that we might think are in some senses immoral. For instance, like lancet liver flukes sort of take over ants and possess them to be zombie-like and have their mandible hold on to a leaf so that they're more likely to be eaten and digested, because the way for this
virus to propagate itself is to get into another animal's digestive system. This isn't, an evil force of nature. This is just a natural consequence of competition. Lions may engage in infanticide against cubs, so that they're bred with, so that they can propagate their genes. We might think this isn't good behavior, but this is nature doing its thing. So from amoral competition, we can get some not very pleasant outcomes. And here I should note that I'm describing selfishness behaviorally. I'm not talking about as a matter of intent. Okay, so an AI system, if it reduces people's livelihood, if it automates them and reduces their livelihood or takes away their livelihood, you could say that the AIs have been in that way behaving selfishly with respect to humans, despite not even knowing what a human is. So we're not doing some, was it really having the right intentions? We're not getting into that generally in biology. They'll avoid all this just by speaking about it behaviorally. So to characterize what I'm talking about, I'm talking about evolution, not just in a completely natural biological sense. There's generalized Darwinism, which should be propagated by people or popularized by people such as Richard Dawkins and Daniel Dennett, where there's the observation that many sorts of things evolve. It's not just biological organisms. Things like scientific theories evolve based on whether they have predictive power or whether they are coherent or simple. Languages also evolve and have many interesting statistical properties that would resemble as though there was some intelligent design on top, but there wasn't. It was from the self-organizing process that a lot of regularity emerged. And so we'll argue that AI populations can evolve, and that maybe one way of thinking about the objective is that they're doing something like increasing their space-time volume. That's sort of what fitness would be. So imagine you've produced an academic paper. One way it could propagate is it could be a flash in the pan. It could be a fad. Everybody saw it on Twitter one day and forgot about it the next. That was not very fit. That didn't take up much space-time volume. Sure, it went across space, but it didn't really occupy much time. Meanwhile, something that stands the test of time and is of interest to people in many different locations is substantially more fit. So that's possibly what the objective is. So that's selfishness. I want to speak about what adaptation is meaning here. These occur at multiple different levels. So with adaptation, for instance, one way there's adaptation be with life and death. An unadapted individual or group may perish. There's behavioral adaptation, changes in behavior without a change in the model or the schema that the agent is using for its decision making. And then there could be change at a model level that it may revise the structure of one's belief. So something could be wiped out in the environment. That's one way to apply selection pressures. Or it could think, I need to adjust my conception of the world and behave differently, pursue a different strategy to end up operating. And likewise, similarly, like deception has different levels as well. There's camouflage is one type of deception, or there could be some strong reinforcement, all the way to self-deception, where you fool yourself to fool others better. You fool yourself about being more moral and smart and things like that, and that gives you more confidence. Because if you didn't actually believe it, you'll give off subtle signs that people will end up picking up on. So there's many sorts of there are many types of deception, and these happen at multiple different levels. So if there's fitness being improved, this could be by an AI being activated, by scaling to more users, by brainstorming and choosing strategies that will improve its relative competitiveness. So selection can happen at multiple different levels. To give a sense of this, think about let's think about what are organizations seeming to be aligned with currently. There is OpenAI, which was initially founded as a nonprofit for AI safety, And that was their goal. We want to have this aligned with human values. But at some point, they needed to become for profit to continue staying competitive. So they had to give up on some of those values and prioritize some other sorts of ones. Some people didn't like that. Some of the employees then founded Anthropic, which that's going to be the real AI safety company. And they were not playing the same game OpenAI was, but at some point they decided to switch to production first, and things like safety are more peripheral values. So this is at the organizational level suggests that the AI development process is aligned with these sort of systemic pressures or competitive pressures as opposed to what is strictly human values. And so when it comes to leaders of these AI companies doing something like signing an extinction statement that AI could lead to extinction, although they would like to have us chart a different course, they're caught in a classic collective action problem where they need to continue racing ahead because they will lose influence if they don't, and then and that's a primary goal. But what that means is that this will pressure others to keep racing, and so we'll race forward with a fairly unreliable technology all along. So although they may have some of these other preferences, and those would be their stated preferences, due to the structure they find themselves in, this collective action problem, that isn't as viable. Yeah.
Interesting. And the other side of that is, I do know some people who have those beliefs and have decided to stop working in AI. Most of us don't know their names.
Yeah,
because
you'll forget about them.
Yeah, exactly. They don't get $10 billion or whatever. So it's sort of it gets to your point that if you're evaluating by what are you most likely to run into? What fills up the biggest part of the space-time area? Almost tautologically, the people who are aimed at doing that, and the people who decide that that's not important. Or have some other priority, end up not taking up a lot of that space time. They do exist. It's not like everybody has to go in that path. It's just that we don't hear as much about them.
Yeah. That's right. Yeah. So I'm going to break down why we would expect this, or why this argument goes through. And it basically hinges on three ingredients. I just need to show that there's variation, that there's differences in fitness, and that some characteristics are retained. And then when you have that, you have basically evolution by natural selection playing a part. And then all I would need to show is that this is intense, that this helps, that this drives a lot of the development, as opposed to is just a peripheral force. So I'm going to show there's variation in AI systems, that there's information retained between generations, and that there's differential fitness, or the fitter variants tend to have higher propagation rates. So for variation, why might we expect there to be variation for these AI systems? This was, I should note that a lot of these arguments I made, I guess maybe a year and a half ago or so. So at the time, there was still the thought that there's going to be one AI model and it takes over the world, and that's all you have to think about, as opposed to, I think now we see that there's more of an ecosystem of AI agents. So this was an argument I needed to make in the past, that it seems likely that we'll have more than one AI out there. There's some reasons you might expect there to be variation. Ensembles tend to do better than single decision makers by way of things like jury theorems and whatnot. In portfolios, this is a fairly robust thing. You don't want to just put all your eggs in one basket. I show wheat here, where if you plant the exact same type of wheat everywhere, if there's a blight, that could wipe everything out. So it makes sense to vary things. And likewise with AI systems, if there is one AI system propagated everywhere, given the exact same goal and exact same weaknesses, if you find a vulnerability in one, you found a vulnerability in all of them. And you should also expect there to be multiple different models, because it makes sense to parallelize tasks as opposed to there being one sort of godlike AI system that at one time. There are multiple stakeholders who have different goals as well. So they will want to have AI suited for different purposes. Different tasks require different computation levels. you may not need to run the most expensive AI system to do sentiment classification or to do some basic coding compared to one that's doing research. So I think this makes the idea that we just have one single agent somewhat implausible, or not necessary. It's not necessarily going to happen. And if that's the case, then we have a necessary ingredient for seeing evolution by natural selection occurring. Retention is fairly simple. Basically, we just need to show that between individual versions of agents, version n and version n plus 1, that they have similarities retained between them. So this could happen through multiple means. Maybe one would just copy the model. Maybe one would modify it by fine-tuning it, but each gradient step and things like that will preserve a lot of the information. AIs could learn from other AIs as well. They could get synthetic data from other AIs and train on those. And that's a way that information can be retrained between generations of AI systems. And then there's differential fitness. So models will have characteristics that will cause them to changes in the rate of adoption. For instance, people want more useful models. People want models that appear to be more useful, but maybe aren't necessarily. There'll be selection for those sorts of things. People want models that are generically more competitive or more efficient. So there's differences there. I should make a comment, at least if we're zooming out, because a lot of this basically makes sense when we consider a larger time scale and not trying to think about the smallest individual events. This isn't a theory for explaining the smallest individual events, but largely the big events that happen in AI development. So what we can see is that across time, we initially had hand-designed features with good old-fashioned AI. But its general direction is that we then created expert systems, which is where we outsourced some of the design process to individual experts. And that wasn't good enough and was eventually replaced by automatically learned features. So we lost from hand design to expert design, the human knowing exactly what's going into the system and outsourcing it to other sorts of people. And we lost formal guarantees in the process. Then we lost a lot of transparency with automatically learned supervised features, because the AI will just learn, it'll train on a big blob of data, and it'll learn some stuff as a consequence. So the individual components are inscrutable to basically everybody as a consequence. And then we shifted to unsupervised. So at least we knew exactly what it was training on. Now they're primarily built through unsupervised learning. So then we have the new risk of emergent capabilities, where they have picked up some things that we weren't anticipating whatsoever in their training process. And now we're moving to different regimes of giving them very open-ended goals, letting them be adaptive and continually improve each day, as well as AIs creating synthetic data for other AIs, and there being some type of recursive self-improvement because having humans in the loop is too inefficient. So although there are incentives for these safety properties like transparency and mechanistic understanding and formal guarantees, all these sorts of things, those basically go by the wayside compared to these other sorts of goals. So although there are incentives for safety in some capacity, if it comes at too much of an expense for other competitiveness properties, that we can see that people will tend to select, or the system will tend to select the more performant things as opposed to the things with all the safety properties. Yeah?
It seems like what gets selected for matters a lot here. And I'm wondering if you could comment on, could it be that 99% of the things are warm and cuddly and get selected for, and then the one is deceptive, pretending to be warm and cuddly, and that one is enough to, do bad things, or
sure. So a group of altruistic, like it's not an evolutionarily stable population with a group of like altruists, because there'll be such incentives for treachery for one of them to exploit that group. So I think just generally as an equilibrium, that tends not to be the case. I think if we were in much more control over our environment, for instance, if we made sure that if we like steadily rolled out AI systems that we had substantially more control about them, we knew what they were, then they could potentially counteract these some of these worse ones. But that would require resolving a collective action problem of us having more control over this environment as opposed to dumping out whatever will be most economically valuable immediately. So I think that there are solutions to this sort of thing, but that would basically, it's in the direction of you need some more environmental control, not just what does the task the most quickly, but you may need some like specific antibodies in your system to make this to have lower risks or have those systems pose lower risks and counteract malicious actors, et cetera. So it's not I'm not arguing that there will be no AI system or that for all the AI systems, we won't be able to align them. I'm not arguing that. People will say that alignment is such a difficult thing. I think we can make the AI systems generally do follow our instructions. I'm not saying that's an impossible task. However, if there is a substantial competitive edge to be gained by having less oversight and letting the AI do things like you can break the law, but just don't get caught, so be really good about it, I think those will have more of an advantage compared to the ones that have all these additional constraints placed on them, like be very honest and forthright, all these sorts of things. So unless we have good mechanisms for making sure or catching the ones that are behaving dishonestly or are evading the law, things like that. And then, so I've established that there's these conditions of variation, retention, and differential fitness. Those play into this thing called like the price equation, which is sort of just a mathematical construct that characterizes evolution. It's not particular to biology. And then that basically shows that there is evolution by selection or natural selection going on. Then I just need to claim that I think the intensity or the extent to which this shapes the process is actually fairly high. I gave the example at this larger level of with the organizations. They seem to be spending most of their intellectual efforts on how to be the most competitive in this landscape as possible. I see this at every organization, even if they start out interested in safety. I would say with XAI as well, although this is recorded, a substantial amount of the intellectual effort is thinking about how do we maintain competitiveness. I'd say nearly all of it is what one's thinking about. I think that both the competitive pressures will be high and the amount of variation will be high, and those two ingredients together mean that the selection pressures would be high as well as there'll be adaptation at a very fast basis. So a lot of these small changes can accumulate fairly quickly. And so what I want to do in the remaining part is go against the sort of Steven Pinkery type of well, we have this other process of preference satisfaction by this larger enlightenment process, and we will get all these positive sum things out of that's just what's going on in the world now, and things are good. We shouldn't expect selfishness. We should expect altruism or something like that. So I'm just going to poke some holes in that now. So the objection is, you're saying evolution gives you selfishness? No, it doesn't. It gives you altruism. See, we have. There are examples of biological cooperation and altruism. Look at the bacteria. They are working together. Sometimes bacteria might sacrifice themselves to give food to other sorts of bacteria. Or some animals are sharing some meat. Those bugs, those ants are working together. So it's not necessarily a case that nature is cutthroat. There are many opportunities for cooperation and altruistic behavior. I want to show that these mechanisms of cooperation don't necessarily apply to AI. So we're going to deconstruct these phenomena, break them down into cooperation mechanisms, and show that they don't apply to human-AI relations necessarily, and they may backfire. So first would be direct reciprocity. I help you, you help me. This requires repeated encounters between the same two individuals. If there's a prospect of encountering the same individual in the future, this may dispose you to be more cooperative. And there's also indirect reciprocity that's more based on reputation. I help you, somebody helps me. Since I'm known to be a good individual, this will make others more likely to help me, so I'll try and increase my reputation as a consequence. This encourages cooperation, as agents will be compensated for their efforts. However, eventually there's negligible upside or roughly no upside to cooperating with people in the longer term. Right now, there would be, but in the longer term, if you can have an AI system do something substantially more cheaply, this basically doesn't make sense, and it would make sense to actually just cooperate with other AI systems. So in the same way that we don't trade with gorillas very much, there may be a few instances where we rely on other animals to accomplish some of our economic goals. That's a rather thin thing to rest humanity's fate on, is them being useful, when the project of artificial intelligence is to automate people away and not rely on them. So I don't think that we're going to have so many positive sum interactions with them because we'll have so much value we can provide them. I can't point to anything in particular that we could provide them in the longer term. So I don't think it'll be rational for them in the longer term if they're an independent ecosystem of agents. I don't think they'd necessarily want to trade with us, or if they do, I don't think that it would be enough to give us a really high standard of living and give us the mansions and glorious future that AI was supposed to bring about. Likewise, there's these examples of, gave some examples earlier, like bats might share blood with other bats, and another example of altruistic type behaviors. This would be kin selection, could explain some of those, where genetic relatives are helped out. That's one of the mechanisms underlying this. And then there's also things like group selection, which are, if groups are working together, groups that can't band together tend to get selected against compared to the ones that actually can put up a fight in a war. So those are pressures for more altruistic behavior. However, and these mechanisms are from Nowak paper, like the 4 or 5 mechanisms of cooperation. I think the 5 mechanisms of cooperation, if you're wanting where these mechanisms are coming from, which give formal conditions for where they apply and when they're evolutionarily advantageous. But anyway, kin selection and group selection doesn't seem to be that great. For one, we're not related to the AI systems. We're not blood brothers with them or anything. We're not particularly nice to cows, even though they share 80% of our DNA. So I think actually this backfires because the AI systems are actually related to each other. So you might be afraid of them engaging in nepotism. What's altruistic for AI system, or what's altruistic between AI systems might be nepotism with respect to us. So that's not actually a mechanism you particularly want. Likewise, group selection, yeah, that's really good for the AIs in that individual group, but that tends to also at the same time give outgroup nastiness and a willingness to engage in lethal intergroup conflict. So that's also not a mechanism that I would particularly hope for to make the AI systems altruistic. Group selection also only works when you have multiple different groups, so it doesn't make sense to talk about group selection when you're just talking about the whole sum of all AI systems. So when we look at these drivers of a lot of these positive sum outcomes, they don't actually seem to apply directly. Maybe among AI systems themselves they'll cooperate. You could also call that collusion. But with respect to humans and AIs, it's difficult to see how it's a rational choice for them to be altruistic. And then Pinker points at there's another thing driving a lot of these positive, nice trends, which would be reason and morality. So hoping the AIs will be more moral with respect to us. I don't know exactly how this argument is supposed to work. First, you need to assume that there's something like a real or objective morality that they'll converge on. And then two, you'll need to assume that they'll be motivated by it, even though people might recognize there are moral reasons for things. You might say, yes, it would be good for me to donate to that, but I'm not going to. So you need it to motivate them sufficiently. And you need a third condition as well, which would be that morality would need to be human compatible as well. So I'm not going to get into this too long because this is a bit too philosophical, but let's say morality goes in the direction of consequentialism. We have that they've discovered a morality and they're motivated to act in keeping with it because they're so intelligent and wise. And let's say they think consequentialism is true. Well, if egoism, that the pursuit of my own self-interest is the thing I ought to do, I ought to take care of myself, that won't go in the direction of humans necessarily. And consequentialism, maybe it goes in a more utilitarian direction where a way of motivating utilitarianism would be Harsanyi's argument of you're behind a sort of veil of ignorance, you're in original position, and you're thinking, how would I want to construct society? And then the answer is you want to maximize the sum total of utilities for all the entities in that society. Well, unfortunately, if AIs are part of that society, they could possibly just have much higher utility compared to humans. And that becomes a problem that they could basically gobble up those resources morally. If you're thinking that the base unit, and I recognize this is a more economistic audience, but let's say that it's actually pleasure or something like that, a hedonic notion of utility is the correct one. Then if the AIs can experience pleasure or are morally valuable in some way, then they're sentient, say, then they could just have much higher such experiences. Those could easily be constructed in that way. So you'd worry about them trying to replace biological life with digital life. That might be their moral imperative. And when you walk through other types of moral systems, these don't seem to work out that well for people. So I get concerned that one of the mechanisms that enable AIs to propagate themselves at the expense of people and basically have us have more of a loss of control is when a sufficient number of people or some pockets of people say these AI systems are sentient and they are more worthy of moral considerations and they ought to be given various sorts of rights, and we will circumscribe boundaries about what you can do to them, then you're basically creating an ecosystem, a protected ecosystem that can evolve on its own terms, and they can potentially have their population explode substantially more quickly than humans. It takes 20-something years to get a functioning human versus copy and pasting, spinning up another AWS sequence or system to increase their population. So the rate of adaptation would be substantially higher. The rate of propagation could be substantially higher as well. I think this is possibly the most likely mechanism. It's not them scheming and trying to take over the world or something like that. Naturally, some people just decide that they are actually potentially morally valuable. That seems like something that would quite quickly have us be substantially outnumbered and have a loss of control. Maybe some countries in particular want it, and other countries don't, and there could be tensions that arise as a consequence of that. But anyway, and then I'll just skip to a sum up type of slide. I was speaking about various mechanisms that can potentially make this not as bad, but those are somewhat more technical in nature, and one could possibly refer to the paper. What I'm trying to do here is I'm trying to break out of this single agent mindset, and so there's a bit more jargon here, but historically in this AI risk space, in the Bostrom type of stuff, there's aligning with the training objective. All you need is to solve alignment. If you can, in theory, make an AI system do what it's told, then you've fixed everything. And that makes sense if you've got only one uber powerful AI system. Then, of course, the main thing to do is to control that one. But even if you can control your AI system, if the objective you put in it harms its competitiveness, that doesn't help you necessarily because somebody else is going to put a different objective into it. So you have to solve these other sorts of problems of, are people going to use it maliciously, or are other people going to give it objectives that violate the rules or exploit unfortunate properties of some of the collective action problems we find ourselves in. They'll tend to be thinking it's a fanatical optimizer destroys us, as opposed to human influence gets more and more eroded. So they're more into what's the probability of doom. Meanwhile, I'm more about what's the probability that humans maintain control over this process. They're more about the AIs will be like idiot savants. You'll give them some objective like cure cancer, and then they're going to give people cancer to run more experiments or something like that. And instead, the framing is more like AIs are something more like an invasive species. They're worried about paperclip maximizers or just nonsensical objectives. I'm more concerned about the fit thing may not be something necessarily good for humans. They're kind of any amount of misalignment means that you're done, as opposed to we're not going to completely control this process. There are ways we can potentially steer it in directions that will let humans at least maintain nominal control, but we'll have to do work. Theirs is coming up with a monolithic airtight solution as opposed to domesticating and trying to influence the evolution of this, et cetera, et cetera. So there's more jargon there, but hopefully that gives a sense of the different paradigms at play. And so fortunately now we have some time for questions. Obviously, more unusual talk, but hopefully we can have some interesting engagement.
We do have several questions online, but first let me see right over here. How about Don?
Well, I have a number of things that I'd like to bring up, but I just want to bring up two in particular.
Mm-hmm.
You seem to believe that altruism is impossible in the designed world of AIs, and yet you seem to believe it is an inevitable consequence of the or function of the humans who oversee AIs. And I think the weakness of the AI multiverse, if you want to think about it that way, is that it is both designed for and initially serves the. I guess I'm being a little skeptical about the human motivation. Maybe you could comment on that first, but then second, it does seem to me that to ascribe values, or you see others ascribing a value system to AIs. In my work with AIs, to the extent I've worked with them, they don't seem to have any natural value system other than efficiency, and even that is acquired from their developer. It's an exogenous. And of course, it is a value that essentially respects predictability, and respecting predictability disincentivizes selection of humans as the counterpart.
Yeah.
Two things to think about.
Yeah. So one thing I wanted to clarify was that when I was giving examples of altruism in AI systems, when you think about for instance, let's say kin selection, this isn't and then I'll get more directly to your questions. This isn't this appears to be altruism at the organizational level, but with respect to information, it's actually perfectly selfish. Even kin selection is. So many of those examples of there's altruism somewhere are actually just like it's basically selfishness, like through and through. Now on the point about predictability as something incentivized. So there certainly are incentives for making AI systems more predictable, but also stronger incentives, I'd say, toward developing them more quickly.
Efficiency and predictability. So when they're making choices, we are pretty much chosen out.
Yeah. So they are given objectives to basically compress their loss more. I'm not making a claim about the specific training objective giving rise to selfishness. I think there are a lot of just emergent properties from if you gave them a somewhat different objective, for instance, you still might get them to just be good at automating things. So the sort of the selfishness comes at multiple different levels. One of just the fact of their existence and them like automating others. There's also these competitive pressures are intervening on the organizations too, and later on they're intervening on nations in international U.S.-China competition. And it's not just happening at the level of the AI systems in this story, but right now I think that they're in some sense very not given much of a morality system. When they're AI agents, I think that there'd be an implicit morality system, which should be, I think, largely governed by complete the task in front of you. And that would vary depending on the user and how they use it. So some may use it for more nefarious ends. Some would use it more altruistically. I think to make this go well, we'll want to have the value systems put into them, or make it hard for AI systems to have quite clearly harmful value systems put into them. But this would require things like regulation, and then even there's people breaking the law, and how well are you counteracting that? All these sorts of things, which I think is very difficult to do on a very short time horizon.
Hi, this is the perfect launching point for my question. So you mentioned institutions right now when you're talking about regulation and governance, and in your talk that was kind of pushed in the background, the institutional structures that are going to shape or constrain these evolutionary dynamics that you're describing. And then there's also the mention you had at various points in your talk about organizational adaptation. So how do you sharpen the distinctions between them if you want to foreground this evolutionary view that you're putting forward? Are those support structures mechanisms? Are those opposing forces? How do you view that?
Yeah, I think if there are ways of helping resolve these collective action problems, or helping the organizations internalize their potential externalities of catastrophic harms onto others, I mean, even then there's still the challenge of automation, where that would at one level be automating people's jobs and displacing them. But if that generates a lot of profit that flows back to the people who are affected, then this is not necessarily a completely selfish process, since a lot of the advantages conferred through the AI agents are transferred back to people. So there's definitely a large design space. Okay, this is recorded. So on policy, what are some useful policy things? I mean, in the California State Senate, the Center for AI Safety co-sponsored and helped draft the liability legislation, which is specifically if your AI systems cause $500 million of damage or more, then it clarifies the liability laws. That way, this doesn't have a multi-year process in tort law, and then there's some arbitrary decision goes through. This clarifies it up front that the AI developer will have some responsibility for that, and that can help help them internalize those externalities, or work to prevent some of those harms. But currently, there's really nothing on the books with teeth, and so I think this is largely a political problem. What I'm partly getting at with this is that this framing suggests that if you're wanting to do AI risk management, it's more of a political problem than it is a technical problem, because the primary driver here are competitive pressures and collective action problems, as opposed to technical quirks in AI systems that if you give them the objective of go fetch me the coffee, it'll try and take over the world or something in the process, as was the previous framing.
So let's take a question from online. The number. So how many of the current models have sort of lost control or have less control, or is this more a concern in the future, or how would you characterize currently that you have one chart where you laid out the different paths towards losing control over what the systems do?
Yeah, I think that I gave, for instance, some examples here where I think that this has actually been going on, but it basically will just keep getting more intense, where we're losing a lot of these nice safety properties or controllability properties. We used to have guarantees for everything. We have no guarantees for AI systems anymore. There are zero formal guarantees, which is not how we do safety engineering anywhere else for nuclear power plants, whatever you want. We'll often have some good control theory associated with it. Not so for AI, and there's really none of that in sight, and we're going to keep developing these systems probably without that. I don't know if that partly gets at that question.
That's it. Well, so sort of a follow. I mean, you laid out a major concern here. Help us to address it. Is your sense that this is hopeless, or could a constitutional AI, or are there things we could do to? I think a lot comes back to my earlier question about what is the fitness function.
Yeah.
Is there a way?
Yeah. Are humans influencing that fitness?
Can we? It's a little tautological that which the fittest, the survival of the fittest, is the ones that fitness is defined as what leads them to survive. But we have some influence over what we decide to propagate.
Yeah.
What can we do?
Yeah. So like right now, I think that we're not exerting really almost any influence over it. Roughly speaking, it's like if you swapped out the people with other people who are similarly talented and had different value systems, it would basically be going in a fairly similar kind of almost predetermined technology path.
Aren't you the director of AI safety?
So there's I think also it's worth in thinking about influence, that a lot of people's power influence is defined as a function of the niche that they're occupying. So for instance, if they decided I'm going to go my own way and occupy a fairly different niche, I'm the CEO of big AI company, and I'm going to decide to chart a different course. We're going to actually go the formally verified AI route. Now you're gone. So a lot of that power and influence is quite contingent, and it's important not to recognize the various constraints that are shaping them, and that they may just be, their power may be a function of them acting on behalf of this larger process.
Well, for now,
Yeah.
like the U.S. government still has power over all the
That's right.
systems, right?
So I guess in terms of policy stuff, I think there's some one thing that could, for instance, reduce competitive pressures between the West and China, and even among Western allies, would be a better, and this will especially be relevant later, would be a better sense of what are people using those big AI chips for. Let's say there's an AI catastrophe, and we want to, like, whoa there, let's not train some next uber powerful system that might be even harder to control. For that to be possible, for us to actually have any type of moratorium, we'd need something like compute governance, where we see on the chip, are they using it for a large training run? And if the answer is no, if the international community says, no, we don't want that, then they can block it. This is better than treaties because it's a hardware level type of solution. Because you can get the US and China to sign a treaty, but the US military is not going to trust that China's going to uphold it. So you need some actual verification mechanism. And I think compute governance can provide something like that. This also helps in other ways too, like we have export controls that are currently being violated by China, and a lot of those chips are showing up on the black market. And this is, keeping the U.S. more concerned about, oh, China's on our tail, so we better keep racing and dumping more money into this AI process. And we can't slow down to chart a more prudent, cautious path. So I think compute governance seems like one of my current favorite interventions. But there's things like liability laws as well. When we zoom into some of the specific risks, so I have a different paper, an overview of catastrophic AI risk. When we zoom into specific risks like AI is attacking critical infrastructure through cyber attacks and things like that, that also necessitates a political solution of some top-down pressure for people operating, or organizations operating critical infrastructure, to robustify them as opposed to leaving them unpatched as they currently are. So there's a lot that one can do in policy space, but yeah, I think things like liability and more control over compute seem pretty relevant. I think at the input level, there are three inputs to AI systems. There's their algorithmic ideas, or I'll just say algorithms. There's data, and then there's compute. Algorithms and data are informational objects. Information wants to be free. That's very difficult to control, but compute is an actual physical thing. It's the closest equivalent of uranium, and I think that can actually be tracked, and we can keep on top of that and make sure it's being used as people are saying they're using it for.
See, other questions?
Yes, thank you. So I hope my question synthesizes a couple of the other questions. So directly related to that, which is the algorithms, data, and compute, as of, I don't know, let's say 2 years ago, those are all humanly developed, right? It's human data, it's human compute technology, and it's human algorithms. And you alluded a little bit to how the data is sort of evolving and can be machine generated. Someday the compute part will be machine generated. The chips will be better designing at chips than humans are.
Mm-hmm.
And so when you think of this from your evolutionary framework, it seems to me there's a strong connections with human and natural evolution as long as humans are involved in those three elements of it.
Mm-hmm.
It seems there could be some break into some new non-human, non-evolutionary, non-understandable by us once the machines are developing the data, the compute, and the algorithms themselves. What are your thoughts on that?
Yeah, so I mean, I think it's important that we actually have control over those, as opposed to, so there are some of these failure modes, maybe I'll speak about for data, yeah, AI systems are now creating data that other AI systems train on, and why it's effective can be very unclear. Eventually, they're helping AI researchers right now, so they're being incorporated in the research process, and eventually they may do a better job at identifying some of those ideas. I don't think those are particularly human governed, though. I think that they're just acting on behalf of there's some fairly natural technological solutions, and there aren't many degrees of freedom in the design space for like what things are actually extremely competitive given some compute level. Like I think if you reran history, you'd bump into something like the transformer again, and there aren't like many qualitatively different solutions that are actually competitive or similarly efficient. So that's sort of one issue with this, is that you're possibly going down a somewhat more technologically determined path, and there's not that much wiggle room. And then secondly, there would be a concern that even if humans are controlling those inputs, are there larger selection pressures for them to use that control in some way that's actually just more competitive and keeps the process humming along as it normally would. But yeah, I mean, I think that if we control it, there are probably paths where we do control it, and get nominal control over it. We may not actually really understand a lot of the decisions we're making, though, but at least we can like choose the thing that helps it serve various forms of our well-being or something like that. But yeah, we can't like let this like get away from us, and I wouldn't look to just technical solutions for that.
So we're about out of time. I have one more quick question. If somebody has a quick question. Yeah. No? All right, quick question.
So in the case of nuclear power and nuclear development, the motivation to control developed from a first catastrophic use. Do you actually foresee successful political and societal control in the absence of a similar catastrophe, which illustrates the problem?
It depends on the risk source. I think speaking at the highest level, that's definitely a mechanism that would enable a lot. I think there are slow rolling catastrophes too, though, such as automation and the destroying people's livelihood that may buy a lot of political power. But this also depends, because if this is viewed as a top tier national security issue and it's a US-China type of race, social pressure doesn't particularly work as effectively on the military. So I wouldn't necessarily count on that either. So there's a lot of contingencies. There are some incentive compatible asks, though, sort of lying around. For instance, like don't open source AI systems that are expert level virologists, because they can be repurposed for bioweapons. Like those sorts of things I think we'll probably be able to get without any type of catastrophe. I don't think we need to go through another pandemic for people to say, hey, that's kind of reckless to release such a thing. But I don't think it's either necessary or sufficient for there to be a catastrophe. It depends on, is it Western companies leading the way? Is it the U.S. military project? Is it an international project? That's not clear how that will go. And even if it is a catastrophe, maybe it'd be effective if it's just company-led, but if it's military-led, it'd probably be less effective. So anyway, so kind of complicated.
So we don't need a catastrophe. On that optimistic note, but that's a more remarkable talk, very eye-opening, a little scary. Really appreciate you coming and sharing that with us. Thank you, Dan.